Some numbers you learn about are just, well, they're just numbers. But every once in a while, you stumble across one that feels totally different. One that seems to be woven right into the fabric of the universe itself, like a kind of secret code for how the world works. Today, we're going to decode one of the most mysterious and important of them all. So take a look at this. This is not just any old portrait. It's a picture of the brilliant mathematician Leonhard Euler, literally built from the digits of the number that would end up with his initial, the number E. I mean, some numbers are so profound they actually inspire art, and this one has a really fascinating story behind it. The number itself, it starts out 2.71828, and just like its more famous cousin, pi, those digits stretch on forever and ever with no repeating pattern, just pure, endless complexity. But that really just brings up the bigger questions, right? Where in the world did this kind of bizarre number even come from? And why does it pop up in everything from the money in your bank account to the way a force grows to how a hot cup of coffee cools down? Well, the story of E doesn't start in some super complex, abstract math lecture. Nope. It actually starts with a really simple, practical question about money and how you could get the most out of it. And this number wasn't just discovered overnight by one person. It was more like a gradual reveal. First, John Napier's work on logarithms kind of set the stage. Then, Jacob Bernoulli literally stumbled upon its value while he was wrestling with compound interest. But it was Leonhard Euler who really dug in, understood its power, and gave it that simple name we use today, E. So here's the little thought experiment that Bernoulli was playing with. Imagine you have just $1, and you find this incredible bank that offers you a 100% interest rate per year. Sounds simple, right? After 1 year, you'd have your original dollar plus $1 in interest, $2. But what if that bank pays you your interest more often? Say they compound it semi-annually, twice a year. Well, you'd end up with $2.25, a little better. What about quarterly? Now you're at about $2.44. And if they compound it every single day, you wind up with about $2.71. Are you noticing a pattern here? Your money is still growing, sure, but the extra little bit you get each time is getting smaller and smaller. It almost seems like it's hitting a ceiling. So what happens if we just take this whole idea to its absolute extreme? What if you could compound that interest not just every second, but every nanosecond? And even faster than that, what happens when you compound continuously? Well, mathematics has a beautiful answer for that, and it's called a limit. And that ceiling, that absolute maximum amount of money you could possibly make from 100% interest on $1, is exactly the number E. And this visual really drives the point home. You see, as n, that's the number of times we compound, gets bigger and bigger along the bottom, the value climbs, but then it starts to level off. It gets closer and closer to that dotted line, but never quite crosses it. It's leveling off right at 2.718. It's leveling off at E. Okay, so this whole idea of a limit, of perfect continuous growth, that is the key to everything. It's what makes E so special. It's like the engine of growth itself. So here's where the real magic is. E is the only number you can use as the base of an exponential function, where its rate of change at any single point is exactly equal to its value at that same point. To put it simply, it describes a system that grows in perfect proportion to how big it already is. When it's small, it grows slowly. When it gets big, it grows really fast. This is the mathematical signature of natural, uninhibited growth. And because of that completely unique property, E becomes the default. The natural base for describing any process that involves continuous change. It doesn't matter if something is growing or if it's decaying. If it's a smooth, continuous process, E's gonna be there. This is exactly why we have the natural logarithm, or ln of x. It's not called natural because it's easy. It's called natural because it uses E as its base. It's the perfect tool that lets us work backwards on these growth problems. It helps us answer questions like, okay, how long does it take for this population to double? So, we started this whole journey with a kind of abstract problem about money, but now we get to see how this mathematical key unlocks all sorts of processes out in the real, natural world. The connection is actually really simple, but it's also incredibly profound. The natural world is absolutely filled with systems where the rate of change is proportional to the amount that's already there. And wherever you find that kind of relationship, you are going to find E sitting right at the heart of the equation. I mean, its applications are just so diverse, it's kind of mind-blowing. We're talking about the growth of a bacterial colony, the decay of a radioactive atom, the rate an object cools down in a room, how your body processes medicine. Even the famous bell curve in statistics has E right there in its formula. It is quite literally everywhere. But of course, in the real world, things can't just grow exponentially forever, right? Resources are limited. Nature always has its limits. And this is a perfect way to see that next step. On the left, you've got that pure exponential growth curve, just shooting up toward infinity. But look at the right. That's a logistic curve. See how it starts out looking exponential, but then it starts to bend and flatten out as it approaches some kind of limit, or a carrying capacity. And can you guess what number is at the very heart of that more realistic formula? Yep, it's E all over again. It's just being used in a smarter way to model growth that has limits. I think this quote just captures the whole feeling of it perfectly. We don't really invent it. It feels more like we just discover it. It just shows up on its own anytime we try to write down the rules for smooth and continuous change. So in the end, E isn't just a number. It's a fundamental principle for how things in our universe grow and change. It really makes you wonder, doesn't it? If E is the secret code for change, what other incredible numbers are out there, hiding in plain sight, just waiting to describe the rest of our world?